Lecture 5, Center of Gravity. It is a point through which the resultant of parallel forces system formed by the weights of different particles of body acts. In other words, it is a point through which weight of the body acts. Consider a body of weight W which is made up of a number of small particles having weight 1, weight 2, weight 3, weight 4, etc. We know that the weights of the body or particle will always act vertically downward because of gravity. W is equals to W1, W2, W3, W4. This is a total weight. This is total weight. This is weight 1, weight 2, weight 3, weight 4, total weight. The total weight is concentrated at this point. This is center of gravity. The center of gravity of this body is acted at this point. The term center of gravity is used for bodies which have mass, but centroid is used for bodies which does not have mass, like rectangle, triangle, circle, just like this geometry. Geometrical figures. Methods of determining center of gravity. The center of gravity or centroid may be found out by one of the following methods: geometrical method, graphical method, method of moments. Center of gravity by geometrical method. The center of gravity of simple figures can be found out from the geometry of the figures. In general, if a figure is symmetrical about a point or line, then the center of gravity will lie on that point or that line. Take for example, this is rectangle. The rectangle, this is diagonals of the rectangle. These diagonals are intersected at this point. We lie on that point or that line. This is intersected at this point. The intersection point is the center of gravity of this point, this geometry or this rectangle. This is L over 2. This is B over 2. Since these are equal, this is B over 2. For triangle, or take for example for parallelogram, the center of gravity of this parallelogram is concentrated. This mass of this body is concentrated at this point. This is gravity of this point, center of gravity of this point. These diagonals are intersected at this point. The intersection point is the point where the mass of this object concentrated. This is center of gravity. This point is center of gravity of this point. This is L over 2. This is H. This is H over 2. Take for rectangle. For triangle, these are diagonals from vertex to opposite side. This is intersection point. This point is center of gravity of this triangle. This is B over 2. This is H over 3. From this to this H over 3. From this to this to H over 3. Center of gravity by moment method. By finding moment about the axis of reference. For example, this OY axis of reference, we calculate x bar. By finding moment about this OX, OY, we find or we calculate x bar. About this moment of this mass is about OX, we calculate y bar. Consider a body of mass m whose center of gravity is to be found out. Divide the body into small parts as shown below. Let M1, M2, M3 and M4 be the masses of the four parts in which the body is divided. The M1, then M1, G, M2, G, M3, G, M4, G be the weights of the four parts 1, 2, 3, 4 respectively, acting through their center of gravity G1, G2, G3, G4. Let the coordinates of the center of gravity of the parties be x1, y1 for M1, x2, y2 for M2 or for central gravity or G1, x3, y3 for G3 or M3, x4, y4 for G3, 4 or M4. Taking OX and OY as the axis of reference. Take these are axes of reference. Those are axes of references. Let G be the center of gravity of entire body having weights mg and its coordinates x bar, y bar. Then now moments of the weights of the parties about OX is m1 g y1, m2 g y2, m3 g y3, m4 g y4. This is total mass and the total center of gravity is equals to m1 for each particles. Center of gravity for each particle, mass for each particle, center of gravity for each particle, mass for each particle. Then the sum of this gives this. Then G cancel G. So my bar is equals to m1 y1, m2 y2, m2. This is equals to y bar is equals to m1 y1, m2 y2, m3 y3, m4 y4 over m total. We calculate y bar is equals to summation of my over m. This is center of gravity of this object, or center of gravity y bar. Similarly, moment of the weights of the parts about OI. M1G XY, X1, M2G X2, M3G X3, this M4G X4. Moment of the weights of the body about OI is mg x bar, the total moments. Total moment is equals to summation of the each moments. Then mx bar is equals to m1 x1, m2 x2, m3 x3, m4 x4. This x bar is equals to m1 x1, m2 x3, m3 x3, m4 x4 over m total. This is x bar. This is center of gravity from OX axis, OY axis. Center of gravity from OY axis. Axis of reference. The center of gravity of a body is always determined with respect to some assumed axis. The axis from which the distance of central gravity is measured is called axis of reference. For different axis of reference, the distance of central gravity will be different. Take this. If we take this OX axis of reference from top, this is 4 centimeter. This point is found at 4 centimeter from this axis. When we take OX from bottom to this, Y bar is 3 centimeter. This is 4 centimeter. This is 3 centimeter. But this is not different. This is at this point. Whatever orientation it is, center of gravity is not changed. Whatever orientation it is. Whatever we take from this or from this axis of reference, this point is not changed. But when we take axis of reference is 4 centimeter, from this 3 centimeter. It is different. Thank you.